Now, this sounds pretty rough, right? 1.5, solving equations with fractions. And the first thing that happens usually with students is like fractions, and then your head explodes, you know what I'm saying? And we can see the leftovers coming out of your nose or something. As though, okay? The fractions. Remember I told you the calculator? I forgot to bring mine today again, but the calculator has the fraction function. You just use that all the time. And nothing else really changes. Well, if you're going to do it by hand, I guess this is important. But whenever you add and subtract with fractions, it is important to know that you need common denominators. If you're going to multiply or divide with fractions, you don't need common denominators. But division, we pretty much always change into multiplication. So how often are we going to use this? Well, I may do things by hand, just because some of you may be curious about it. But for the most part, like if I were you as a student, I saw 7/3 plus, I don't know, 9/11, I'd just put this in the calculator and be done. Okay, you're welcome to do it by hand. I will never object to that. But I'm going to use a calculator if I was in your shoes. So with multiplication, and hopefully we know this already, but if not, it's a nice review. With multiplication, you multiply the two numerators together, and with multiplication, you also multiply the two denominators together, straight across. Boom. Now, I did mention, I think last time, that you can use cross simplification, which if you are familiar with, you may use. If you want to wait till the end to do cross or simplification, you can. It doesn't matter. It just needs to be simplified in the end, which, by the way, no surprise, the calculator will do for you. So division, again, if you can do this by hand, what I've heard people call this keep, change, flip. I don't know. I never divide with fractions if I'm doing it by hand. I always change it to multiplication. That way we have less rules to remember. But you see how the second fraction there, the divisor is flipped on that one. That's reciprocated, but it allows us to change that operation into multiplication. So what's the solution? By the way, this slide hasn't changed since last time, the other 4 times we saw, right? So remember that a solution, the reason it's because it's important. If you don't know, like when you're solving for x, it's like x is just the value. No, it's the value that you replace into the original equation to make it a true statement. That's what it is. Right? So what value of x will make this equation true? That's what we're trying to find out when we want to know what the solution is. Principles of equality. Hey, what do you know? Last time we talked about it on Tuesday. They haven't changed since. Okay, so whatever you do to one side, you just got to do it the other side. And once again, with multi-step equations, you just may need more than one of these. So multi can be 2, but technically we call those 2-step equations. I don't know, that's kind of boring information. Now, fractions, as it turns out, fall into principles of equality. So when we see a problem like this, all I'm doing, look, this problem right here really is no different than seeing this. I'm using the 2 numerators here, all right? But last time when we went over a problem like this one, some of you guys wouldn't even use a principle of equality. You'd be like, dude, I know the answer is 3. Hey, that's freaking awesome, okay? But I'm going to use principle of equality because, use a principle of equality with the fraction. So what would you do? You'd say, I want the coefficient of b to be a phantom 1, right? How do you make a 4 coefficient a 1 coefficient? You just divide it by itself. But since it is a principle of equality, if you do it to one side, you're going to have to do it to the other side as well. So 12 divided by 4, boom, 3, right? And then you can make that a phantom 1. Okay? Look, it's not going to change at all. It's not going to change at all, even though we're dealing with fractions right there. So see the coefficient right here? That's that coefficient there is 4/3. So I'm gonna take that 4/3. I want it to be just a 1, phantom 1. So I'm going to divide it by itself. Okay, so I'm going to show it with fraction form division. There we go. I got my divide by 4/3 on the left. It's with fraction, but on the right, I'm going to show it with division. Is that what? That's okay? Yeah. It's still division. I'm just showing it in a different way. Wait, so you can show things in a different way and not change the value? I've already said yes, but I don't know how many times you're going to have to do this before you guys believe me. It's true. You can do that as many times as you need to, right? Could I have shown it with a fraction like this? Sure, you could have. But since I'm doing this by hand because I don't have my calculator with me, that it's better to do it horizontally like this. Well, what happens to my coefficient of b? Well, 4/3 divided by 4/3, really anything divided by itself is 1. So mission accomplished there. So I'm left with my phantom 1b right there. But I still got the 12/5 divided by 4/3 there. So I'm going to have to work with that. And remember, I don't know, again, some people say keep, change, flip. I just say reciprocate the divisor and then change the operation, but whatever. 12/5 now, I'm going to change this operation into multiplication because I don't want to divide with fractions. Again, I never divide with fractions, although you're welcome to. It's just if I do that, I got to reciprocate this fraction. Reciprocate or flip. Same thing. Now it's 3/4, okay? Now, I'm doing it by hand. The calculator would have been done by now. I am going to, I'm not trying to be snarky about that, by the way. It's encouragement. But the 12 and 4, I can cross simplify these. They're both divisible by 4, so that's 12 divided by 4 is 3. 4 divided by 4 is 1. And now I'm left with 3/5 times 3/1. And yes, you can have ones. But in the numerator, remember fraction multiplication, 3 times 3 there, 9. And in my denominator, 5 times 1, 5. 9/5. I guess I wrote that kind of small, sorry. It still works. B equals 9/5. Let's check. 4/3 times 9/5. Well, I'd simplify the 9 and 3. That'd be 4/1 times 3/5, and then 4 times 3 is 12. In the numerator, 1 times 5 in the denominator, 5. 12/5. So that does check off. It shows that B replaced with 9/5 would give us a true statement. Now some of you guys are like, Sal, that wasn't anything like this one on the right.
Yeah, I got a question.
Right? Part here is, yeah, why do we show this? It's because I wanted you to see that this principle of equality, just divide on both sides. You can do that with fractions, no problem. And it works out pretty good. Well, this one did have this extra step, right, with the reciprocation of the fractions. I mean, did we really have to do that here? Of course not. You could, but I don't know why you would. That was one principle of equality. Remember, we're going to see some bigger problems now, right? So we're going to solve this equation. Negative 3/4 y plus 9 equals 2/3 y minus 5. Let's go ahead and get started on this one. And a couple different ways to do this, but I'm going to stick to the way that we did it last time in class, okay? Let's make this a little bigger. Now, there are other ways to do this. Okay, some of you guys have heard of this. Can we make the denominators all the same? Yes, you can. It's just proven perilous in the past, so I tried to avoid it. Okay, so I'm just, if we can work with fractions, which your calculator will do. So, let's go and make some big decisions right here, right? Like a Bob Ross painting, putting trees in front of everything. I want the y's, because most people prefer the y's on the left. Okay, so I got my y's on the left, numbers on the right, okay? Now, I put those labels there. They don't mean anything other than I know where stuff should go, right? So I'd say, look, here's my term, negative 3/4 y. It's on the correct side with the y's, right? But I got plus 9. It doesn't have a y. It's not a y term, so it has to, well, it has to zero out. So how do I zero out a plus 9? Subtract 9. But if you do it to one side, you should do it to the other side. Some of you guys are worried because you may have put the y's on the other side of the equal sign. It still will work. You'll see. Right? Or you may have subtracted something else first. And that again, it should still work. I'm doing this one at a time, so let's move from left to right here. I'm going to go and drop this negative 3/4 y. Of course, those 9s, 9 minus 9, that zeroes out. So again, I'm not circling it. That's an actual 0. This will equal, just drop the 2/3 y. And then we have the final operation here. That's negative 5 minus 9, which is negative 14. Of course, that reads minus 14, but it's a term, negative 14, okay? So now, I don't have any other non-y terms on the left side. But now I do have a y term on the number side of thing, okay? So I got to zero that out. How do you zero out 2/3 y? Just subtract it from itself. Remember, when we want to create 0, we use the addition or subtraction principles of equality, right? So subtract 2/3 y, and there's our equal sign there. So that does zero out. Anything subtracted from itself zeroes out. Negative 14, let's go and drop that, negative 14. And then I got negative 3/4 y minus 2/3 y. Oh, geez. Let's do this here on the left, okay? So I'm going to do it by hand. I know some of you guys got calculators, but I just forgot mine. I guess I could pull one up. Negative 2/3. Why am I not including the y's? Because they're both y terms. I'm going to end up with some number of y's no matter what, okay? So I got negative 3/4 minus 2/3. Once again, I'm going to use that same strategy of forcing the denominators to be the same because I am subtracting, so I do need them to be the same, like we saw before. So I'm going to multiply the 3 denominator into this first fraction. That's going to be negative 9/12. I'll still keep the subtraction. But then we'll multiply the 2 and 3 by the other denominator 4. So that ends up being 8/12. See, and that forced the denominators right away to be the same. Is it the lowest common denominator? No, but all we really need is common denominators. It doesn't have to be the lowest. Okay, so when I combine these, I should be looking at 12ths, no matter what. It's just how many 12ths is it? Well, you got -9 minus 8 of the 12ths, so that should be -17/12. So what do we see here? We got -17/12 y equals -14. No problem, man. We can, we can divide both sides then by the coefficient, -17/12. And we'll need more space, but -14 divided by -17/12. Well, you know what? I'm going to use a calculator on this one. But first, coefficient of y is a phantom 1. This equals, there we go. I can pull one up.
12?
Bam. 168/12. 17ths.
17.
There we go. That's better. I'll try to remember my numbers better. Now, how do I know this is simplified? Because that's what the calculator pushed out. So if it would needed to be more simplified, it would have. It would have done it. In fact, some of you may know how to change the improper fraction here to a mixed number. I don't care. We don't need to because, like I said, the section should want pretty much all the answers as improper fractions there. This one does set up different. Okay. However, and some people say, well, where's the fraction, or what's the coefficient right here? Okay, and if you can understand this, then nothing changes, it just changes the way that it looks. Okay, and that's okay, right? We've learned that you can change the way things look in mathematics without changing the value. So, what I would like to see on this is not just n over 4, but 1n over 4, because I am now going to change that to 1/4 n. Wait, you're telling me those have the same value? Yes, they do. And that comes from fraction multiplication. So this is just a different way to show that, okay? Now, did I have to do that? No. But I hope that it helps. Okay, so maybe I'll do this one twice. And so this next one, right? That's 1n over 2. I'm just going to make it 1/2 n. I'll keep the plus between them. This equals 7/5, right? Don't need to change that. Okay, well now we see the fractions, we see the coefficients. In fact, is there any like terms to combine? Yes, there is. We got 2 terms with n's, so I can combine those. So let's go and combine those n's together. So that's 1/4 plus 1/2. Let's go and do that. I'll do that here in the top right. 1/4 plus 1/2. This one's not too bad, you know, because I want 4 is a multiple of 2. So I mean, could you use the other method? Yes, you could, but you would require some simplification. Whatever. The calculator can do it too. So I'm going to multiply these both by 2, the 1/2, because I want the denominator to be a 4. This does it. The numerator, though, is 2, right? Remember we talked about that example. So now I have 1/4 plus 2/4, which is the same and has the exact same value as 1/2, but now I have forced the denominator to do what I want it to do, not the other way around, right? So how many fourths is this? 1/4 and 2/4? That's 3/4, which means I now have 3/4 n. This equals it still equals 7/5. A problem like this, it should look familiar by now because we did do one, what was it, 2 problems ago? Maybe 3. So let's divide both sides by the coefficient 3/4. You know what, I'll do it like this because some people prefer it like this. Not that it matters, it's still division, but divide by 3/4, right? Anything divided by itself, phantom 1. Okay, so I will divide the 7/5 though, also by 3/4. If you prefer to see it that way, do it. It's still going to make that coefficient of n a phantom 1, right? So now I got n equals 7/5 divided by 3/4, which really would be 7/5 times 4/3. 28/15. That's what I got. So this was the original problem. Could we have worked from this problem from the beginning this way? Yes, we could have. Now I'm going to do it a little bit differently. Doesn't mean you have to do it with either of these methods. No, maybe you have your own method, and that's fine too, right? But whatever the case is, I do have like terms, still 2 n terms, but I still need the denominators to match or to be the same. So I'm going to force them to be the same. without having to change these into 1/4 n and then 1/2 n, okay? So what am I going to do here? Well, same thing. I'm just going to multiply the 2 denominator by 2, and that's going to force that denominator to be 4, right? So there's 4. But now, well, I'm going to show this as 2n. Hopefully that's okay. And then what do we got? Well, we got n over 4 plus 2n over 4 equals that 7/5. Sorry, it's kind of small. Well, we can work with that because now that the denominators match, I can now combine these fourths. How many n's would that be? That'd be 1 n and then another 2 n's. That'd be 3 n's. It still equals 7/5, by the way. Well, we're looking at pretty much the same problem as we have over here on the left, okay? But it's shown differently, and if you want to show it this way, that's fine. But I'm gonna have to use 2 principles of equality if I show it this way. Not that you have to, but you could. So what am I gonna do? I want to get rid of that 4 denominator by multiplying this side by 4. But if I do it on one side, I got to do it the other side, like this, okay? What does that do? It makes the 4 as a phantom 1, which leaves me with 3n equals, now I'll make that 4 over 1, 28/5. Okay? And then I would finally divide both sides by 3, give me the coefficient of n being a phantom 1, which is just what we want. So mission accomplished here. I'll show the extra step, even though maybe not everyone wants or needs it. I'm going to make this 1/3, okay, because that was 3 over 1. So I flip the fraction, change the operation. 28 times 1 is 28 in the numerator. 5 times 3 in the denominator, 15. Same answer. It's just a different method. That's it. All right, here's another one. Well, this is the first one. I guess we've seen some distribution, right? No problem, because it's just, fraction multiplication, which we've seen. Remember, you do not need common denominators when you multiply with fractions. So a couple things on this one, though. See these 2 terms right here? They're not like terms, so don't even look to combine those, okay? Or these 2 inside the parentheses. Can't do that. So if you're thinking order of operation stuff, nope, can't do that because there's nothing to do on the inside. So in order to simplify this, we're going to have to use some distribution, rainbows. That should make you happy. But let's go ahead and distribute that -2 into the parentheses. So -2 starting, -2 times 2/5 x. So I'd make that -2 over 1. That's going to be -4/5 x. And then distributing it to the -8 would be -2 times -8. That's going to be a positive. So plus 2 times 8, 16. Okay, so there's our distribution. And then on the left side, we didn't do anything. It's the same values as we had before. Okay, so I'll just bring that down. This looks like problems that we just barely did. There's no combining like terms, but we're going to have to get the x's on one side. Now, again, most students prefer to put the x's on the left, so that's what I will try to, I'll try to stay consistent on that, okay? So the 1/2, let's zero that out because it's on the x side of things, right? You can even, like I said, you could do that, what I did earlier, put your letter on the left and then the numbers on the right, so you know which side things should be on, right? 1/5 x, it's good, it's on the correct side, but the 1/2, no good, got to zero that out. So subtract 1/2. Okay, that's going to give us 0 there. We'll get to the 16 minus 1/2, but 1/5 x, going to drop it. This equals, I'll drop my -4/5 x as well. And, sorry, I don't know why that happened. But 16 minus 1/2, I would say 15.5. What is that?
31 halves.
Thank you. If you guys did that in your head, that was impressive. 31 halves. Okay. That looks pretty good. So now I got the -4/5 x on the incorrect side, right? So I got to get rid of that garbage. Get rid of, I mean zero out, right? So subtract 4/5 x. But if I do it to one side, do it to the other side. So that's going to zero that out just like we want. 1/5 x minus. Thank you. So 1/5 x plus 4/5 x, how many fifths is that? That's 5/5. I'll get to simplifying that here in a second. I know some of you guys are ahead of me. That's pretty freaking awesome. I already zeroed out the -4/5 x. Let's drop the 31 halves. And, give ourselves some more space there. So, 5 divided by 5, what do you know? That's 1. Yeah, that's just, no need to divide by the coefficient here, it's already a 1, just make it a phantom 1, and we end up with x equals 31 halves. Couple ways to do this one. And you could use common denominators, which is really all we end up doing in the end. I don't like that method though, because it can cause confusion. So here's what I'm going to do. I'm going to do something probably you're a little bit more familiar with, and this is called cross multiplication. Okay. So with cross multiplication, I take the crossing numerator and denominator and multiply these. All right. That would mean that I'm going to take x plus 3, and I have it in parentheses because I'm multiplying that whole numerator by 4. This should equal the other numerator and denominator cross multiplied. Cross multiplication. So 2, and then I'd multiply that completely by x minus 1. So I do need that set of parentheses there, okay? What about that 4? It's on the wrong side. No, it doesn't matter. It's still multiplication, so I can distribute from this end as well. Okay, so 4 times x, that'd be 4 x's. And then 3 times 4, that'd be positive 12. So I get 4x plus 12 on the left. On the right, I got 2 times x. Distributed would be 2 x's. And then 2 times negative 1 would be negative 2. Distributed. Boom. All right, well, hey, look, not even any more fractions at this point. Well, not even at the last point, but don't have to worry about those. So here we go. I'm going to do this a little bit different than last time. I'm going to do the 2 steps in 1 step, because we can. And I do want my x's on the left, the numbers on the right. So the positive 12, the plus 12, I'm going to zero that out by subtracting 12 from both sides. So that zeroes that out just like I want. But on the right, I got negative 2 minus 12, which is negative 14. That's doable. But the 2x in purple there, it's on the wrong side. So I'm going to zero that out as well at the same time. Yes, we can do that. Remember, we're just lining these up with like terms anyways. So I just saved myself some space, maybe even some time, but at least some space, okay? And what do you know? 2x minus 2x, that does zero out. And now we got 4x's minus 2x's. So that'd be another 2x's right there, okay? So this is the final part of the equation. 2x equals negative 14. Just divide by both sides by the coefficient 2. X equals negative 7. Well, let's check. This one should be pretty easy. Negative 7 plus 3, that'd be negative 4 divided by 2. That's negative 2. Okay, so I know I get negative 2 on this left side. What about negative 7 minus 1? That's negative 8 divided by 4. That's negative 2. That may be better too. So it checks off that it is true. Now I know that x equals negative 7. If we go back to the beginning here, what you could do is you could force the denominators to be the same. Why would you do that? Because if you do, you can get rid of the fractions. And since we all hate fractions, sometimes it's the method of choice. Doesn't have to be though. So see that denominator 2 and the denominator 4, I can force them to be the same by just multiplying this one by 2. See, that makes it a denominator 4, but if I do that, I got to do it to the numerator as well. Right, so I don't change the value of the fraction. So that ends up being 2 times x plus 3, and then this, well, it equals what we still had up there with x minus 1 over 4, like this, okay? So now that I force the denominators to be the same, and this may look a little weird because I'm doing it a little bit different, but I forced the denominators to be the same. I could have multiplied, for example, I guess this side by 2. I have to think about that more before I say that out loud. In any case, the denominators match, and so then I would have 2 times x plus 3 equals now just x minus 1.